Welcome back. In our previous lesson, we have already finished designing the user interface. In this lesson, we will write the code. So we have a timer here, and the timer is set to be triggered every 1 second. If you click on the timer, you will see here. So every 1 second, the timer will be triggered, and the timer is going to check whether or not the debugger is attached. So let us now write code for that. So we click on the timer, and then over here go to the events and double click on the on timer event. That will create the event handler for the timer. So every 1 second this function will be triggered. So we can put our code in here. The first thing we want to do before we write the code out, we need to create some global variables. So we open a space on top here, and we're going to create a bool. Bool is a variable which can either be true or false, and that bool is called debugger detected. Initially we'll set it to false, so this will keep track on whether the debugger has been detected. And then inside here we are going to check whether a debugger is detected by using an if statement, and then the function is debugger present. Is debugger present is a Windows API function that can detect whether a debugger has been attached. So if the debugger is attached, this will return true, and it will use the whatever is in the code block. So we are going to set it to is debugger detected to be true. So this is what we are going to do. And then once you have set this to be true, there is also an else part. The else part is if the debugger is not detected. So you are going to set this to be false. The flag. This is a flag. A boolean is also a flag. So it detects whether something has happened or not. So that takes care of that. And we are also going to change the status of the label. If a debugger is detected, we are going to change the status to say debugger detected. So let's go back to the code. Under here we are going to set the label. So the label is called label status, and we are going to look for its caption, set it to debugger detected in bold, in caps. So let's make sure that the name is correct. Alright, we forgot to rename the label. So let's go back to the label here, click on it, and then in the property, change the name. Under properties, change the name to label status, and then go back to the code. So now it's correct. And then if the debugger is not detected, we want to set the caption to debugger not detected. So we copy this line and we paste it in the else part and save. Now next thing you want to do is click. Whenever we click on the button here, we are going to check whether the serial key is true or not, correct or not. And at the same time, we also want to check whether the debugger is detected. If the debugger is detected, we are going to close the program. After showing a message box, we will close the program. So let's double click on this to open a new event handler for the button click. So inside here, we are going to extract the string that the user entered, the serial key that the user entered. So we are going to create a string called serial key, and the code here is similar to what we did in the earlier CrackMe. We extract the text from the edit serial box. The edit serial box is this one. So after you extract the text, we will save it to a variable called serial key. And then we are going to check whether or not this flag is debugger detected is true or false. Okay, here I forgot to change the message. For the else part, it is supposed to be debugger not detected. Okay, so now we are going to copy this variable and put it in here. If it's debugger detected, that means if it's true, we want to show a message box. The message box will say program will now quit because you have detected a debugger. And the caption will say debugger detected. And we're going to use a OK button and also error icon. And then after the user clicks OK, we want to close the program. So we use the terminate function. Application terminate. So if the application is terminated, the program will close. If the debugger flag is false, that means no debugger, then it will continue with the next line. So this line will only be reached if the program has not closed. So here is where we test the serial key, whether it's correct or not, by using the compare function. And we are just going to use a simple serial 1, 2, 3, 4, 5, 6. So if the serial key is the if the serial key is correct, then the function will return 0. The compare function will return 0. So if the serial key is correct, we want to give a congratulatory message. So I'm just going to copy this line and paste it here. And here I'm going to say correct key. Alright, there's an error here. This should be L for long. And here I'm just going to say correct key. And here the caption will read thank you. However, If the serial key is not correct, then we will have an else part. So in the else part, we are going to show an error message. So I'm going to copy this line and paste it in here. And over here, I'm going to say sorry, wrong key. And here I'm going to say error. Alright, for this icon up here, I forgot to change the icon. So here I'll put icon asterisk. Okay. So I think the code is all done. Let us build it first and see what it looks like in the meantime, to make sure the user interface is okay. Yeah, it's okay. So if we enter something wrong, it says sorry, wrong key. If we enter the correct key, it says correct key, thank you. Alright, so now we are going to attach a debugger. I'll open up x32dbg and attach to our CrackMe, and it says debugger detected. If I click on this, it says debugger detected, program will now quit, and the program shuts down. This is how we create a CrackMe with anti-debug protection.